of you who like the Amstrad chassis, and it works well in my opinion, especially the genuine Japanese one. And I've said before, you've got the Hong Kong cheaper version, then you've got the fake one, and then you've got this. You've got the Spinneytonic CB199, which is the fake Amstrad chassis, specially made for Littlewoods mail order catalogue group. Now you'll also see another version of this, which has overstuck Harvard, the H646. The Harvard H646 is the mail order returns of these revamped and sold on to Harris Overseas Limited. So in actual fact, there's a possibility that we could say the Harvard H646 is better than the Spinneytonic, because at least it was reworked in the UK when the sets got rejected. This is a set, well, I will have bought off eBay, because I wanted to show one. The only thing that really I find is a letdown is the squelch. It's much cheaper parts, so the reliability is not going to be there. And usually they've lost the power connector, and this is no exception to that. But there's nothing I can do about it. I can't order another power connector. So this is a made in Hong Kong. It's got the wrong screws in it. And if they've widened the holes, we won't be able to put M3s back, which is a shame. So the difference you will see immediately, which I've been talking about before, apart from can't open it up. Oh, that's because they've screwed it together wrongly. They've not tucked the top and the bottom in correctly. That's going to take some pulling apart. Oh, done it. Right. That's the first lid off. I should have put the soldering iron on ready, because it's going to need it. Hello. What's all this wire? Apart from snapped and joined together. Oh dear. Someone buy that man a soldering iron. So the difference, straight away, is that the printed circuit board is not screen printed. So if we look at the same chassis, this is a Fidelity 2001, but it's the same chassis. If we look at that, and I'll just zoom in, so you'll be able to see that the component locations are screen printed on the printed circuit board. On the fake version, the components aren't screen printed on the printed circuit board, and it uses cheaper parts. So if we look at, I'm going to probably be called a liar now, but it does. See if I can see anything. These colours are supposed to be, is it by a firm called Wonder or something like that? But on the, well, actually I go to the foot of our stairs, because the fake one has got taco coils in it, which are actually higher quality. Amazing. Now the interesting power lead, which we'll sort out later, unless I can find a scrap set with a socket on the back, but to be honest I think that's highly unlikely. I mean, at the end of the day, it's one of my sets and it doesn't really matter because it isn't going anywhere. I wonder what fuse they've put in there. Oh, you look, a 13 amp mains fuse. That really protects, and there goes the door. So back to the job in hand. That was a fellow radio ham who was a member of our club. To the door, he'd broken down quarter of a mile away. Could I give him a jump start? Trouble with these -4 temperatures with car batteries. So, back to the job in question. We'll deal with that later, as I say. We'll see whether the set's repairable. It's one I'd have bought off eBay, as I said, specially bought in. So we'll plug our standard Cybernet mic in. Oh, it's got some writing down there. But it looks like it has anyway. So we need to put a fuse in there. Make sure that's reasonably clean. Probably redo the whole power lead, to be honest, if this radio's working. The stripy one's positive. Yep. Switch on the power supply. So let's see what we need to do. Tone to middle, squelch to minimum, RF gain to full. Instruments in. Not sure which is PA and which is CB. Let's clean that dirty control. Okay, let's go in for transmit. 3 watts. Good 3 watts. Now this is a set that we really need to keep an eye on the VCO. So I'll just make sure it's somewhere near on channel 20. And if it isn't, we'll go through the procedure in the manual. Sorry about the tannoy. Our scanner's picked up something on one of the few ham channels that's programmed in, so we don't normally expect anything to come through unless it's within a mile. So it's the far side of that capacitor. So 2.5 on receive, 2 point something on transmit, channel 40, 1.9, 3.5, we've got a minus number there. That's not right. I'll have to get the manual out. We use the Amstrad manual. So what do they want us to do? Because I can never remember. VCO alignment. So it's capacitor 9 and ground. Just make sure I am on capacitor 9. Just in case it's different. Yeah, capacitor 9. That's 23. Just move the camera down so you can see. So that should be 9. That will be 23. Yep, that's correct. So well, I'm in the right place. So let's just see what they want us to do. So they start on channel 1. So we're on channel 1. And they want receive. I think these are a floating chassis. That could be where I went wrong. No, it's not a floating chassis. So they want 2 volts. Channel 1, receive. Kind of widen the shot so you can actually see the meter. So there we go. And then in transmit, still on channel 1, also 2 volts. That's fine, that's within 0.1. If we needed to adjust it, I'll tell you what, we will. We'll just have a go with CT1. No, it's a bit closer at that. And 2 on receive. So go to channel 40. This adjustment is the most important thing on anything that uses this chassis or even the fake chassis. Because otherwise you end up with channels dropping out in different temperatures. So now we're on channel 40 and we should be somewhere around 4.5 volts. And they only do transmit. So why have I got a minus voltage? It isn't Earth, is it? I think we'd better just start again with me actually on the negative of the power supply. So we'll go back to channel 1. So 2 volts and 0.62 on transmit. So that's our transmit, and I've dropped off the point. Receive, transmit, receive. Back to channel 40. 3.5 as a positive voltage, or 3.56. They're expecting it to be between 4 and 5. So at least we've got something like we're expecting. So that's now in lock. So I'm going to move to channel 20, which is where we're doing the rest of everything. And now we'll see what we've got on the power meter. So we've now got 3.2. It'll soon drop though. So just go up the tune up. I think that uses the green hexagon tool. To be honest, it doesn't look like it's been messed with, this, which unfortunately this chassis can suffer from. I don't know what's happened to that coil, we'll just see. So at 3.5 watts, which is what I expect. I'm going to look at the spectrum analyzer in a moment, but we'll just do the deviation while that boots up. So the deviation's 4.5, which is ridiculous. So we'll just turn that down to 2.2. I think we should be about there. While actually, can do with coming up a fraction. Wallow. That's it. It's not like AM FM, you know, where they used to turn them up as high as they could. On FM, it gives you worse range if it's too high. It's like trying to get a fat bloke through a narrow doorway like me. Not going to happen. Chop the sides off. Okay, I'll just press the auto button and see whether that picks us up. And we'll go over to the spectrum analyzer. So there we have, I can't see it from here. Oh! Oh, I've got 708 megs coming from somewhere. Probably the radio cell phone tower down the road. I'll put it in manually. Frequency 2779125. Enter. So we've got a bit of something there. It's nothing to worry about. Just look at these coils. The screwdriver expert finds that when you stretch these out, they get more power on the Zetagi meter. But in actual fact, the power isn't on 27 megs. Talking of Zetagi meters, we'll plug our Zetagi meter in to see what 3.5 watts mysteriously becomes and magically becomes. Look at that, more than 10 watts. Wow, my pretend Amstrad's doing 10 watts. And when we put it on the real meter, we are doing 3.5. Right, on low power, and this isn't adjustable, so it's absolutely as it comes. It's doing 0.45. So that's that covered. Let's look at the transmit meter. So we're getting all the lights. We should only really be having the first 4 lights up. So we'll do the RF. I think it's that one. I might be wrong. trouble is my curly cord got stuck on the side of the bench. I'm totally wrong, it's not that one at all. Perhaps it's that one under there. It is. There we go. 4. So now, if I turn it to low power, chances are it'll be 1. It is. Back to full power. 4. So it gives some reassurance that the thing's transmitting. Unlike modern sets where they don't have real RF meters on very, very few. It's just a bit of bar graph pretend. So that's covered that. So, oh, let's see if it's anywhere on frequency. Just select camera 2 and should be 2779125. 2779112. So it's slightly low, it's within tolerance, and as these age, of course, the crystals drop, so eventually you get to the stage where it won't trim up anymore. I'll tell you what, this one is. I'll tell you what, I might call these fake junk, but this one's working. There we go. Check we've still got deviation. Wallow, we have. Just listen to that on our monitor receiver. Testing 1 2, testing 1 2. Sounds great. Okay, we'll turn over to the receiver now. So we'll select the oscilloscope and we'll put 2779125 on the signal generator. Might be recapping a Fidelity 1000 tomorrow. There's some interest when we did that Uniden, because I never thought it'd make any difference, but it did. So as a bit of fun, we know Fidelity 1000s are about as bad as they come. It's not going to make the bleed over better, but it might do some other parameters. I've had enough parts come, and the trouble is with this coronavirus, parts are in short supply, and I'm not getting some deliveries till July. So we are here, what is it, the 12th or something, 13th of February today. I don't want to wait till July, so I think we can do most of them, and the ones we haven't got from the make particular brand I want to use, we will have in stock in a good quality brand anyway, but I did want them all to be the same whatevers. So there we are, let's see what we're getting, if anything. Oh, it's dire. Absolutely abysmal. At the moment, we're doing actually 0.65 on the SINAD meter for 12 decibels. But it sounds like the detector's well out. So the detector's down there. We'll put an S9 signal on the signal generator. Turn the volume up so we can actually see the waveform. We want that to be maximum. It's that one there. So we have got maximum there. I've just got to knock the IF out. No, we'll soon have that back right. So turning to the SINAD meter, I'll just put that right. Really sounds like the IF's out. Oh, it doesn't sound very good, does it? Let's go back to the detector. Just see whether I can bring that up a fraction. Nope. So that's 0.3 of a microvolt. I'll go through the front end again. Well, I can't expect it to be like an Amstrad genuine set, can I? So it sounds pretty awful. 0.3 of a microvolt. So we're getting, for 12 decibel SINAD, we're now getting, I misread it last time, I got 0.61, it's 0.6 now. On 10 decibels, getting 0.55. For 20 decibels, surprisingly, it's quite good. It's 1.5 microvolts. So there you are. That's as good as we can align it. But at the end of the day, it's a cheap copy of the Cybernet 002 EV chassis. So we'll see how it sounds on air. I'll put that soldering iron back on, and we'll put the signal generator to S9. And we'll set up the S meter, which is presumably the one I messed up. There we are. S9. Turn the signal generator down, it goes down, turn it up, and we might even get plus 30 eventually. Not with this signal generator, we won't. Right. So that leaves the squelch. So set the squelch to full. It's a bit dirty, that control, so we'll clean that one as well. May as well clean the RF gain while we're at it. So set squelch set to full. This is where these, I think, are a letdown. So we're parked at the moment at 0.3 of a microvolt, so 0.1310. I want it to be stronger than that. So we'll just see if we can adjust that. That's on full. And it's coming in at 30 microvolts. That's as good as the radio is going to achieve. So at the other end of the scale, we'll turn the signal generator off. So we're now in standby. Turn the squelch down. Set threshold. Switch the signal generator back on. Actually, that tracked quite well. Came in at 0.3. So I'll put the lids back on. So we should have watt wires. We've got these wrapped around, which is all very well and good, but it's so easy to break the thin wire going to the speaker cone. Tell you what, we turn picture in picture off. I've got some sharp cutters on here. The RS Pro ones. You know what, it's safer just to snip. There we go. That can go in the bin. Tip the debris out. The foggiest where the other wire is. Let's look on a scrap chassis. So we have what? There's a yellow wire supposed to go to the left of the green wire. So we'll pinch a bit of yellow wire out of this set, not the yellow wire, because normally they clip on. Because this speaker's now being soldered, I don't think that's ideal. So I'll just switch off. Right, let's see whether we can put the lid on successfully. Not sure what the sellotape's for. You know what, before we do that, I think I'll put them through the dishwasher, so we'll come back to the video in 20 minutes. So just before putting it back together, we've just had a bit of a snag which has taken some time to actually fix. And when I connected the speaker, I got no audio output. So I put the wires in. You remember the wires were missing. One of the wires was missing, and I discovered that one of the sockets, the extension speaker socket, was actually open circuit on its switch. So I've replaced that, and the protection diode was missing. So I've replaced that. Sorry, it wasn't missing. It was short circuit, and the print was burnt out. It acted like a fuse underneath. And then, in actual fact, one of the reasons Mr Screwdriver Bodge had got that wire dangling, he'd actually got it going to earth somewhere instead of to... And he got tape all round. You've got this tape all round. You need to kind of insulate the chassis. Because there was a short circuit capacitor there. So I've changed that. And hopefully, when I solder that speaker in, we should have audio. Let's just tin that. There's a limiting resistor for the speaker on these sets. Now, at first I thought that was perhaps open circuit. That isn't the case. I plug the aerial in, switch the power supply on. We have audio. So in conclusion, we now have hopefully a radio we can switch on. Too noisy? It sounds like he's too noisy. One under Roger. Thank you. Roger, Ancaster. Well, we don't often get a 19. He's 4.5 miles away at Cranwell. Well, turn the squelch down. Right, well, we'll leave it on 31. We'll do a test later on with Mr Chippie. So that's the Spinneytonic CB199, which is the fake Amstrad 901 board, as fake as it comes. But at least I've got it to work. And at least we've had somebody on 19. So there we go. Thank you for watching.